All right, guys, so continuing on, this next example, I felt like it didn't give me enough information, so I had to stop the video and look up the number of points for each grade. So for example, look at number 4. It says the grade point average is a classic example of a weighted average. Last term, a student's grades, this bar is going across the words, I can't really read that part of the sentence. Anyway, it wants us to compute the student's GPA for a term. So this is very typical for college classes. If you take a physical education class, it'd be great to make an A on it, but that A is not going to count as much toward your overall GPA as an English class or this philosophy, or especially biology. I really can read, you guys, because your science classes usually have a lab and they're going to be worth more credit hours. So the way colleges count grades is that A's receive a 4. So if you received an A for a class, that's 1 credit hour. So 1 times 4, that's a total of 4 points. Total of 4 points. All right, so B's receive 3 points. So 3 points per credit hour. So 3 times 3 is 9. C's receive, oh, I think I'm putting this in the wrong column. Let me back up. All right, so A's receive a 4, B's receive a 3, and C's receive 2 points per credit hour. So since this philosophy class is worth 3 credit hours and you made a C, so 3 times 2 is 6 total points toward our GPA. 3 times 3 is 9. You earn 9 total credit hours for this English class for your GPA. 4 times 1 is 4. And then finally, 5 times 3 is 15 points for your total GPA. So when you add that up, you get 6 plus 9 is 15, plus 4 is 19, and 19 plus 15 is 29. So you got 29 points for your grade point average. But then to figure out what that computes into, you have to divide it by the total number of credits. So 5 plus 1 is 6, plus 3 is 9, plus 3 is 12. So basically, you're going to divide 29 by 12. So 29 divided by 12. So for this semester, you earned a 2.4. 2.4. Okay? So does that make sense? Now, these numbers weren't given to us. That's basically what colleges use for each grade. For, A's count as 4 points, so on and so forth. So this didn't give us quite enough information. We had to use our own knowledge to know this column right here. All right, but like I said, that's very standard for college classes. All right, so you guys try that. So you're going to try doing the same thing. You're going to figure out how much this student earned for each of these classes for their grade point average, and then you're going to calculate their total grade point average for the semester. So you're going to do the same thing. So remember, A's are worth 4 points, B's are worth 3 points, and C's are worth 2 points each per credit hour. All right, try that and then come back and check your answer. All right, so I decided to go ahead and try to make a column like they did here. I want to know the grand total of points. So I'm going to multiply 4 times 3 and get 12. And then 4 times 3 get 12. 3 times 2 is 6. And 3 times 4 is 12. So that's a total of, let's say we have 36 plus 6 is 38. So we're going to divide 38 hours by how many total hours we took. So we have 9, 10, 11, 12, 13 total credit hours. So we're going to divide 38 by 13, and we get a 2.9. So we did a little better this semester, 2.9. 2.9. There we go. All right, let's move on. So we're going to talk about variation in this next section, how much a set of data varies. and we're going to talk about outliers. So measures of central tendency, which is what mean, median, mode, and range are concerned with finding the most accurate center point of representation, of representative point for a given data set. If we want to understand how spread out the data are, then we need to look at the variation of the given data. All right. So it says, order the following from least to most variation. So we wanted to talk about how close data, different data numbers are to each other, or how spread out they are. So imagine letter A. So it says the weights of all adults. So if we think about adults as being 18 years and older, and we count the weight of all people in the world that's 18 and above, that's going to be a huge variation, right? Well, then if we said, what about all adult women? Well, is that a little bit more specific? Yes. So there's a little less variation in all adult women than when we're talking about the weights of all adults. So now it gets a little bit more specific than that, and it says, what about the weight of all 20-year-olds in the world? Well, we're getting to a smaller pool of people, more specific. And then finally, what about all 20-year-old women? So that's going to be the least variation than the other groups. So these are actually in opposite order. So since it wants from least to most, then the least variation is going to be group D. And then the weight of 20-year-olds. And then going up to more and more variation, B would be the next group. And then the biggest group, the biggest variation would be letter A, the weight of all adults in the world, or whatever group we're talking about. All right. So it says the range is the difference between the largest and the smallest value in a set of data, and it provides the most information about how spread out the data are. So we're talking about, so imagine if we're putting people in order from shortest to tallest. Well, let's say you have 50 people and the range of heights is only 4 inches. So the shortest person to the highest or tallest person in 50 people is only 4 inches. Well, that means that they're all very, very, very close to the same height. There's hardly any range of heights whatsoever, right? That means they're very close to the same height. However, if we talk about 50 people and the range between the shortest person and the tallest person is 3 feet, well, we're talking about, that's a lot of variation. We're talking about short people to very tall people, and their heights are going to be much more varied if they have a bigger range than the group that there was only a 4-inch range. Okay, so that's what we're talking about here, how varied heights are, how varied weight is, how varied whatever it is that you're talking about. So to find the range, you want to always, if you're saying, well, the average of this group is the average of the class got on their last test was an 85, and the range in the class was 4 points. Well, that means that everybody got almost the same, grade. But if the average is 85 and the range in scores was 20, that means that people could make, one person could have made or even 40. That means that one person could have made a 60 and one person make 100. So that's much more varied data than if the range is small. All right, so anyway, moving on. So we want to know, what is the difference in the highest value and the lowest value? So these are whatever they are. So if this is ages, and we want to know what is the range of ages, well, you have to figure out what is the oldest person in this group. Well, the oldest person in the group is 43. And what's the youngest person in the group? Well, the youngest person in the group is 1. So that's a big range, isn't it? So what is the range of this whole group? The range of the group is 42. There's 42 years between the oldest and the youngest person in the group. So we could find the middle. We can find the middle, or we can find the average. But that range tells us that we're dealing with people that are varied in their ages. Okay, so the range of this group is 42. All right, so range is probably the easiest one to find just by subtracting the highest and the lowest numbers. So find the range of number 8, and then for these 3 problems at the bottom, let's go back and review a little bit. Let's go ahead and find the mean, median, mode of all 3 sets of data and throw in the range this time. And then look at your directions. It does say to round your decimals to 2 places when necessary. All right, so go ahead and pause right here and try these out and then come back and check your answers. All right. All right, sorry about that. So number 8, our range is 11 because 11 minus 0 is 11. That's our range. All right, so let's look at letter A. So just so that we're all on the same page, let's go ahead and put these in order from least to greatest. So letter A, our smallest number is 3. Actually, there's 2 3s, and then we have a 4. We have a 5. We have a 6. We have an 8. We have a 15 and 17. And did you guys count how many you wrote down? I hope so. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at me. I missed a 15. That's why it's so important. There's 2. Oh. It's so important to count and make sure you get them all, you guys. All right, so there were 2 15s and a 17. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got them all now. All right, so just for the sake of time, I'm going to use my calculator. 17 plus 15 plus 15 plus 8 plus 6 plus 5 plus 4 plus 3 plus 3. And I'm going to divide by 9. So did you guys get 8.4? So your mean is 8.4. All right, and then for the middle, we're going to subtract. We're going to mark off high, low, high, low, high, low. There's an odd set of data, which means we have one middle number, which is a 6. And then in this situation, we have 2 modes. We have 2 modes because the 3 repeats and the 15 repeats. So you can have 0 modes, 1 mode, or 2 modes. And then finally, the range is 14 because we're subtracting 3 from 17. Okie dokie. All right, so let's look at the next group. So we have a 2, we have a 3, we have 1, 2, 4 4s. No, we don't. We have 3 4s. Just kidding. I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 numbers. Let me write that down so I don't have to recount them. All right, so let's go ahead and add them. I have 25 plus 5 plus 4, 4, 4 is 12 plus 5. 2 plus 3 is 5. So 47 divided by 7 is 6.7. 6.7. Did I add those up right? 5, 12, and 5. Yep. All right, our middle number, we have 7 numbers, so there'll be exactly one middle number. So we have a 4, and then the mode is also 4. And then a range is 25 minus 2, which is 23. So that's a big range, isn't it? And then finally, letter C, our smallest number looks like a 2, and then we have a 3, and then we have a 5, 6, 7, 8, 9, and 32. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 32 plus 17 plus 13 plus 10 divided by 1, 2, 3, 4, 5, 6, 7, 8. So our mean is 9. Hope I'm getting these right. Y'all let me know if I don't. And then our median, 1, So our median is between 6 and 7. What comes halfway between 6 and 7? 6.5. Our mode, do any of our numbers repeat? Nope. So we have no mode. Now don't put the mode as 0, that's a digit. The mode is not 0, it's no mode. And then the range is 32 minus 2, so we got a big old range of 30. Hopefully you guys got all those right. All right, so now it says find the mean, median, and range for these sets of data. So we're on example 9. All right, so we have 6 plus 11. 6 plus 5 is 11 plus 3, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 divided by 1, 2, 3, 4, 5. So our mean is 3.6. Our median, the reason I didn't put them in order is they're already in order backwards. So this is low, high, or they're already, excuse me, they're not even backwards, they're in order. So the median is 3, the mode is 2, and the range, oops, ooh, what'd I do? The range is 4. All right, so the next example, I have 1, 2, 3, 4, 5 numbers again. And this time I have 25, 26, 27, 28, 29, 30, 31, 32. So 32 divided by 5, 32 divided by 5 is 6.4. So my mean this time is 6.4. The median is the same, the mode is the same, but the range, look how big the range is. 20 minus 2 is 18. So basically what they're doing here is they're introducing the word outlier. So if you notice these two sets of numbers, they're exactly the same except for the last digit. So the last digit in set A is 6 and the last digit in set B is 20. Well, there's a big difference in 6 and 20, correct? So look what changed so much. Two things changed so much. It was the mean and the range. Even though all the other numbers are exactly the same, the mean went from 3.6 to 6.4. With very small numbers, that's a big difference in means. And the range went from a range of 4, only 4 points between separated the lowest and the highest, to 18. So if you have an outlier, it's going to really make a difference in the mean and the range. If you notice on both of these sets of data, the median and the mode didn't change at all. And that may or may not happen in other sets of data, but the mean and the range will definitely be changed. So that's the point that is being made right now on the outlier. So it says outliers are values that are far removed from the other values in the data set. In the above example, data set B has an outlier of 20. Notice how the measures of central tendency and variability are impacted. So like I said, the mean and the range show the big difference in variability because of the outlier of 20 in the second set of data. All right, so let's look at this. We have different countries around the world and the birth rate per 1,000 population per year and the population of the country. So it says a table presents information in rows and columns as shown in this example. So we have birth rates and populations around the world. This is from 2011. So what do they want us to know? They want us to figure out which country had a birth rate of 17.79. So here is what they're talking about right here. So what country goes with that number? Well, it has to be Brazil. Which country has the smallest birth rate? So we're not talking about population, we're talking about birth rate. So we're looking at these numbers and we want to know which number has the smallest birth rate. So of course that would be Bulgaria. And it just so happens to have the lowest population as well. Which country has the largest population? So we're not looking at the center column anymore. We're looking at the population over here. So India. There's only 2 countries in the world with over 1 billion people, and India is one of them, India and China. So the country on this chart with the largest population is India. So basically they just want you to make sure that you can read a graph correctly. If you're, when it asks you a specific question, make sure you're finding that specific column. Don't be looking over here at population when they're asking about birth rate, so on and so forth. So I'm sure you are all great at reading graphs. All right, here's another kind of graph. This is a circle graph. Some people call it a pie graph or a pie chart. And what it does, so a whole circle or a whole pizza, if you ate the whole pizza, you ate 100% of it. So when you're looking at a pie graph or a circle graph, it's always based off 100%. So they have divided it into percents. Sometimes it won't be divided into percents. Sometimes it'll be divided into numbers. This time it's percent. So for all circle graphs, if you add up all those percents, 100% of the time, they should end up with 100% because that only makes sense if you're talking about a whole circle. All right, so this is a person's income, how they spend their money. So they spend 13% of their money on food. They spend 5% of their income on entertainment, 6% on healthcare, 35% of their income goes for their housing. And the key over here, it doesn't contradict the pie chart. It goes along exactly with it. So, this key is not even really necessary because each sector of the pie graph is also labeled. So if they only had colors and not the word food, then you would need this key. But right now it's kind of redundant. All right, so let's look at some questions over this pie graph. It says, how much of their income does the average American spend on health care? Well, the whole thing, you can see that 6%. So how much of their income? So basically, you have to know what the total amount of money represented on this pie chart is. Well, if you look at the directions, the description, nowhere on this pie chart does it tell us how much is our total. So for letter A, all we can do is answer this question as a percentage. So how much of their income they're not asking how much money is spent on healthcare because we don't know the total amount of money this is based on, but we know that on average, Americans spend 6% of their income, whatever it is, on healthcare. Letter B, for the average person, what is the single biggest category of expense? Well, obviously that's the biggest sector of our pie graph, which is going to be housing. Now letter C gives us an actual amount of money. So suppose your monthly salary is $2,200. Because we know the total monthly salary, now we can figure out how much money is spent on food. So since 13% of the income is spent on food, we could figure out what is 13% of 2,200. So remember that was from our last unit. We turn our percent into a decimal and we multiply. So 2,200 times 0.13 is $286. Where'd my pen go? So $286. And like I said, we can only answer that question because they gave us an amount of money here at the bottom. All right, so you guys try. Is there more? Yeah, I think on the next page, I think you have more questions to answer on this. Let me see. Yes, is that the same? No, that's a different question. So go ahead and answer this question, find the number of people who volunteered, and then go ahead and try number 5 on the next page as well. And I'm going to go ahead and end this video. I had to answer a text, and then on my next video, I'll start with this slide and the next slide.